Let's take a look at some more advanced timer applications. Before we do this, I want to take a minute and go over the time concepts once again, okay? So, what we need to remember when we're doing these is that the first part here, normally open or normally closed, that can just be drawn as it's shown, okay? So let's start with this first one. It's normally open, so I can draw normally open right there using the gravity rule. And then it's timed closed. Well, in order for this to close, it's going to have to go that way. The arrow indicating that it's going to move up, okay? Now, this is an on-delay timer. So what happens is when you energize the coil, it's going to start opened, and then it's going to be closed. Okay, so that's an indication of how an on-delay works. It's going to change the state from what is shown. So it's going to start as open and it's going to finish closed, therefore that's an on delay. Let's try another one here. We got a normally closed. So I'm going to draw a normally closed and it's going to time open. So therefore it's going to have to go this direction and it's going to have to open up. And once again, it starts out closed and it's going to open. Therefore it's an on delay timer, because it changes the states between here and here, okay? Let's take a look at normally open, timed open. So we're going to start right here, and it's normally open, so that's what we're going to draw. And then it's going to time open. Well, it's already showing as being open, so that must mean that at some point it has to close so that it can open again, because it starts opens and finished open. So we're assuming that if it closes, it must then time to be open. And this is an off delay timer because where it starts normally open and then it times to where it started, that indicates an off delay. So when they change here, on delay, this is an off delay. Normally closed, time closed. Let's take a look at this. And so this is normally closed, and it's going to time to be closed. And so how does it time to be closed? Well, that must mean that it's going to have to open. So at some point this is going to open, and then we have to close it again. And this is an off delay. So what's the difference again between the on delay and the off delay? The on delay, when you energize the coil right here, it starts timing. And then it switches states after, 10, 20 seconds, whatever you set it to. Energize it, it times out, and then it moves in the direction of the arrow, and it changes to close, or it changes to open. When you remove voltage to the coil here, it then returns to the normal state again, and it would be open and closed. Now, these are the off delay. So when you energize the coil, well, what they do is this one's open, well, it closes so that we can eventually then open it again, because that's what it says. And this one is closed so that it's going to open. So when we energize the coil, they change their conditions, their states. But they don't start timing yet. We have to remove voltage to the coil here, and that's when the off delay starts timing, and then they return back to their normal conditions here to where it was normally opened and it times back to open, and this was normally closed and it times back to closed. So that's the big difference. On delay gives voltage and it times while I have voltage. This gets voltage and then you have to remove the voltage, and that's when it starts timing. Times on voltage, times on the removal of voltage. Okay? So we got a couple ones here that were from the lab circuit, and I'm going to leave a little bit room on this side over here for my diagram, because I wanted some type of timing diagram or something on there. So we have a motor starts 15 seconds after a button is pressed. Okay, so this is a momentary push button, so I'm going to need memory here. So I'm going to go ahead, I'm going to need a relay. Okay, so I'm going to take a push button here, and it was 1 PV, and I need a relay. Well, I'm going to use a timed relay, because a timed relay has contacts that act exactly like a control relay, and those are the instantaneous contacts. So if I use the timed relay instantaneous contacts, that's exactly just like a control relay with a memory circuit, okay? So I have a motor starts 15 seconds after I do this. So I push this and I turn on this timed relay. I'm going to make this an on delay relay, and I'm going to set it for 15 seconds, okay? So then after 15 seconds, what do I want to occur here? Do I want, by energizing this, would I want this to close and then open, or would I want this to open and then close? Well, I think what I want is, to make, because it's an on delay here, I think I want this to start open, and then after 15 seconds, I think it should close. So if I go with 1 TR here, it's normally open, it's time closed. It starts 15 seconds after that is pushed. So that brings it on. 15 seconds later, I get the motor starter to come on. Okay? And then it says the motor runs for 45 seconds. Well, I need a second timer here, because the first timer, the purpose of this was to give me a delay before the starter. The next one is going to, I need another timed relay here. And I'm going to make this an on delay as well. And I'm going to make it 45 seconds. Okay. And then what I'm going to do is I need something to turn this on. So I guess the motor starter could turn it on. Okay. I could have used this same contact, or another one of these instances of the contact here, because basically the timed relay came on, and 15 seconds later I need this to come on and this to come on. So I could have used that. But hey, if this comes on, it closes that and starts that. So this goes 45 seconds. And what do I want to do with that? Well, I want a normally closed contact here, and then I want that to open. And I want it to open after 45 seconds. So at 45 seconds, this will open. When this opens, what happens? My memory's gone, and so this is going to go off, because that's going to open up to my memory. So when this goes off, well, this is going to open. So the motor stops. This opens because the motor stopped. And then this timed relay right here, well, that just goes back and resets as well. And then so this is closed. So now we're exactly back to where we were started again. I could push the button, get memory, have this time and start this, have this start the timer, have the timer open this up, kill the timer, kill this, kill this, kill this, kill this, reset that, and I'm ready to go again. Okay? So that was the first one from the lab. Then it wanted a timing diagram. So I can go here like 0, what's it, motor runs for, I'm going to go in 10-second increments. 20, 30, 40, 50, 60, 70. Okay. So apparently a motor starts 15 seconds after 1 PB is pushed. So I put 1 PB right here, and I was coming along, and I just pumped up pushed 1 PB momentarily, and I got it to come high right at the 0 second mark. Well, then what happens? It says that I have this 1 TR that was low, but that comes on right here, and that's going to come on, and it gets held on, and so it comes high. How long will it be held on? We'll have to see. I have my motor starter here, 1 motor starter, and that was doing nothing. But apparently this is going to come on 15 seconds after this time relay starts. So here's my 15 right about here. So this goes 15, and the motor comes on. And the motor runs for 45 seconds and then shuts off. So also what happens at this point, 2 TR, because when this one timed out, it turned on the motor and the second timer. So this was just coming along, and then so this second timer came on as well, okay? So this second timer times for 45 seconds. So that would be at 60 right here. And at 60, this runs for this long. This 1 TR runs for this long. And then what happens at 60 seconds? This hits 15 plus the 45 is 60. Well, this opens. And if this opens, then this goes low. And if that timed relay gets reset, well, then this goes back to normally open, so the motor goes low. And if the motor goes off, then this opens and this TR goes off. And then we're back to where we started before. So that's an explanation of the first one. Let's take a look at the second one here, and we'll leave another little area there for that. And it says, a motor is started by pressing 2PB. So I'm going to go ahead, and I'm going to give myself some memory here again. Okay. And I'm going to go ahead and give myself 2PB. And I'm going to, a motor number 1, so I'm going to go with 1 motor starter. Okay. And I'm going to give myself memory. So there we go. Motor 1 is started by pressing the push button. Boom, that motor is on and it's holding itself on. Okay. And it's running. 15 seconds after a second push button is pressed, so we're going to do it, we need a second push button here. And this was actually called 1PB. So that gets pressed. And what this is going to do is it's going to turn on 1TR. And I'm going to have that hold itself using the instantaneous contacts. So I've got two things running now. I've got this motor starter running and I've got this time relay. They're independent of each other. Somehow I just pushed this one, you know, at some point. But then 15 seconds later, I want this motor to stop. So what I'm going to do is I'm going to make this an on delay for 15 seconds. So after 15 seconds, I'm going to change this into a normally closed timed open. So I push this at some point. 1, 2, 3, 4, 15, that opens, that motor's dead. This is still on though, okay, because I haven't done anything with that. Motor 2 starts when motor 1 shuts off. Okay, well, if this turned motor 1 off, let's have this also turn the second motor on, okay? But this one would be open and it would be closing. This one opened after 15 seconds. This one closed after 15 seconds. And when this one closed, we got the second motor to go. So now I got this motor running. This one's off after 15 and immediately this one comes on. Okay? And then this one runs for 45 seconds and shuts off. Well, we need another timer. What starts it? Well, it could be this again, or it could be the second motor starter. That's the same thing because this started the starter starts this. Okay? And so what that's going to do is turn on a second timer. Okay? I'm going to make this on delay, 45 seconds. And then what do I got? After 45 seconds, I'm going to go ahead and open up this rung right here. Remember, this rung right here already opened up when that timed. So I'm going to do another one. I'm going to do another closed, timed open, 2TR. And what will that do? After 45 seconds, this opens. Well, that turns off the time relay. And because the time relay goes off, this opens and that goes off. This opens and that goes off. And that closes, and basically we're all set to go ahead and do it again. Okay? So now the timing diagram is going to get a little crowded here. Let's see if we can figure it out. I'm going to go 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. I'm going to go every 10 seconds again. Okay, so what we have here is I have my 2PB. And I'm coming along here, and I guess I just bumped my 2PB real quick right there. Okay, momentarily press it at 0 seconds. And so what happens when I do that? I have my motor 1 right here. Well, that was low, and all of a sudden that's coming high. Okay? And as a matter of fact, when this motor comes high, it motor 1 is started by pressing that, and it doesn't really say when I push the next PB. So let's just say I let this run for about 10 seconds right here. So there's my 10 seconds. At the 10 seconds mark, I decide to push the next PB, which is right here, 1 PB. So that was low. And then right here, I just momentarily pushed that second PB right here. Okay, after 10 seconds. Could have been a minute, could have been 10 minutes, whatever. This time is not important here. It's when I push that button. And so what happens? I get 1 TR. So 1 TR comes on. When I push that, it comes on. And it holds itself on. Okay? And it times for 15 seconds. So here's 10, 25. So there's 25 right there. I went a little too far. So what happens at 25? Well, at 25 seconds, this opens. So at 25 seconds, this goes off because the time relay is on. Okay? And then at that 25 seconds, remember it's 10 plus 15 because this was 15, this shuts. So I got 2 motor starter comes on. So at 2 motor starters at this time, this motor went off and this motor went on. What else happens at that time? The second TR comes on. So that 2 TR comes on right here. First motor off, but the second motor and the second TR are on. Okay, now let's see what happens. Well, its second TR right here is going to run for 45 seconds. So here I'm at 25. So 30, I'm going to go out here to 70 seconds. I'm at 25 plus 45, 70 seconds for the second TR. That's when that second TR becomes activated. And what happens when that becomes activated? Well, what it does is it turns off, it opens up, and it turns off the first TR. Okay? So this second TR comes out here, and it shuts off the first TR because that opens. If the first TR gets shut off, well then this opens. It goes back to the way that it was, the normal state. And so the second motor starter, well, that's got to go off either as well. Okay? And then because the second motor starter went off, that's what had turned on the TR. So that opens, and so this TR goes off as well. Okay? At which point, everything is zeroed out. And I could start it again by pushing this or pushing this. Okay? As something to notice here, I could push this push button right here, and it would start the second motor here, and the second motor would run for 45 seconds and stop, even if I hadn't pushed the first motor. Okay? These motors are independent of each other. Okay, so that's kind of what the lab was asking you to try and analyze a couple of these right here, right? So on the next page, I'm going to flip this over. We have a little Jeopardy game. And so we've already did Jeopardy, and so we're going to draw the Jeopardy game up pretty quick here. In order for a Jeopardy, we needed a reset. We basically need a couple of holding circuits here, right? So what I'm going to do is I'm going to have player 1, and player 1, if you remember, turned on a control relay, and let's say it turned on a red light for the first player. And then we did a control relay right here to hold it. So there's our start of our Jeopardy game. This is just a start-stop circuit. If you hit start, you get memory and a red light. We have 2 players, so we're going to come down here, and we're going to put a second player. Okay, player 2, and they're going to do a second control relay, and they're going to have memory for theirs, and then they're going to have a green light to indicate that they have answered the question right. Okay, so we have 2 holding circuits. The reset will break either holding circuit. Now what? Well, we need interlocks. We talked about this because we can't have both players trying to answer the question at the same time. So the first 1 CR, we'll put a closed contact here, so that if this person gets memory, well, then the second person can't answer the question. And then we'll take the second control relay and put their electrical interlock here, 2 CR, so that either one of those can do it. Okay, that's our Jeopardy game that we went over. Now, this is different. The player has 5 seconds to answer the question, at which time their light goes off. So, we're going to keep going here. And so, if this person or this person tries to answer the question, that has to start a timer. That starts a 5-second timer. So I'm going to come right here, and I'm going to have the 1 CR or the 2 CR, because either person gets the same amount of time. So 1 CR or 2 CR, this becomes true, and we're going to start a timer. And it's a 5-second, and I'm going to make this an on delay. So 1, 2, 3, 4, 5, what do we want to do? It says that at that point, your time is up. We could have a contact here, a normally open time closed contact, turn on a buzzer. That'd be great, wouldn't it? That's usually what you hear. But we also want to, turn the lights off here. So at that point, I guess we could just kill this whole circuit right here. So about here, we had a normally closed timed open, right? And had 1 TR. Well, after you hit your button, after 5 seconds, it's exactly this opens up, and it's exactly the same as if somebody had hit the reset and that you didn't get to answer your question. And that was the other thing that I was saying. We could have had, another run here, which would have been a normally open time closed, and that could have went to a buzzer, right? So that this buzzed, right? And then we'd have to do something to hold this on, to have another timer, to have it buzz for a while, because as soon as this times out, this opens, resetting everything, including the timer that opened this up, and then it would shut again. So the buzzer would need another timer before it reset everything. It's a little more complicated, but I'm sure we could figure it out. Now we have one more cascading timers here. Let's do another one. And we just want to draw the diagram. So another motor, we have the motor is started by pressing a momentary PB. These are looking familiar, I hope. 1 PB. And let's turn on a timed relay. And the timed relay, we're going to use the instantaneous contacts. It's acting just like a relay, and it locks itself on. So this timed relay has to turn on. The motor will run for 15 seconds and then turn off, okay? So what we want to do is we want to have this timed relay right here. Turn on a motor. So that motor is running. Hit the push button, instantaneous contacts, the motor's running. But it runs for 15 seconds and then turns off. So what do we need? Well, we need a time contact here. Time closed, and it's going to open. So this not only turned the motor on, but after 15 seconds, it opens up and the motor stops. Okay. Once this motor turns off, a second motor will start. So what we need is this time relay turns off one motor, but it turns on another motor. So this one is open and it's time closed. Okay. Once again, this timer, after it times out, it's an on delay, 15 seconds. This one opens, this one closes. This one goes off, this one goes on. And then it says that this one runs for 45 seconds and turns off. Well, before we were having the second motor starter start the next timer, we could actually just run this in parallel if we wanted to. And do another timer like this. Could have been an on delay, 45 seconds, right? And then what? Can you figure out where this goes? After 45 seconds, it will turn everything off. Okay? Well, we take it up to the very top rung here, and we have it normally closed, and we time it open at 45 seconds. This opens, which turns this off and kills the memory. Opens this up, which that motor would be off anyways, but it's definitely going off then. And then, because that timer reset, this opens, that motor goes off, this gets reset, that closes, and it's all set to go again. Okay? So these are some examples of cascading timers and on-delay timers and contacts. And hopefully you can take a look at these and understand them. A good way to go to understand this is go through and figure out the timing diagrams. Like this one, you could go through and figure out the timing diagram right here. And try and look for this point right here that might be confusing, of when that times out after a certain amount of time, you know, what does that do? When that goes off, it turns off the other items that it's associated with here with these contacts. So when those timers go and these contacts change state, you can see how they turn off or on. So that's a little more on advanced timers.